Alright, so today we're going to be looking at simplifying basic radical expressions, like the ones you see on the screen. And what we want to do here is we want to break this down into the simplest form possible. And the simplest form is characterized like this. We want to have some number, let's call it a, times the square root of some number b. And what we need here is we need b to be as broken down as possible. Just labeling it as A, B, D, A, P. As broken down as possible. And let's look at what I mean by that. So before I do this, it's important for me to understand what a prime factorization is, because that's going to make this process a lot easier. For example, with 45, a prime factorization would be me breaking this down into all prime numbers. So if I consider 45 is by doing 5 times 9. And so 5 is a prime number, but 9 is not a prime number. So I want to break 9 down into further numbers, like 3 times 3. And now, since all of these numbers are broken down into prime numbers, 5 times 3 times 3 does get me 45, but this is helpful for me. The thing that's helpful here is this. 3 times 3 is essentially 3 squared. And if I know about square root algebra, I know that I can break this up into the square root of 5 times the square root of 3 squared. Now, what is the square root of something squared? We may remember that the square root of some number squared is always that number, because the square root and the squared operations are inverses. So I can think of the square root of 3 squared as just 3. Which means instead of writing it as the square root of 5 times 3, I can write it as 3 times the square root of 5. Now let's compare this to my simplest form. Do I have just some number a? Yes, I have 3 times 5. And is it as broken down as possible? Yeah. Well, there's nothing else I can break 5 down into that will get a square root out. So that works for me. Now let's look at another example. I have the square root of 20. What would the prime factorization of 20 be? Well, I know one way to get 20 is by doing 4 times 5. So why don't we do that? 4 times 5. And now I'm going to break 4 down into the square root of 2 and 2. So it's square root of 2 times square root of 2 times 5. And it's important here to point out also that you may have been thinking in your head, why not just do 10 times 2 as my first step? Well, if I break down 10 into 5 and 2, I'd get the square root of 2 times 5 times 2, which is the same as what I have here. So as long as you're breaking every number down into prime factors, it doesn't really matter which route you go as long as you end in the right spot. And so here we can recognize that 2 times 2, that's just 2 squared times 5. And then I'm going to break this up again into 2 squared times the square root of 5. And 2 squared, the square root of that, is just 2 times the square root of 5. And this is going to be the complete simplest form of this radical expression. And here we have one more example. I have 10 times the square root of 245. So I'm going to leave the 10 in front, but let's start breaking down this 245. You may need to grab a calculator here and start dividing it by some numbers, but I happen to know that 245 divided by 5 is equal to 49. So that means 5 times 49 is equal to 245. You can check that yourself. And then 49 I can break down into 2 prime numbers, which is 5 times 7 times 7. And don't forget the 10 in front. And now our similar process of realizing that this is 7 squared. And I'm going to reorganize this into 10 times the square root of 7 squared times the square root of 5. And the square root of 7 squared is just 7. So this is 10 times 7, which is 70 times the square root of 5 as my answer.